Okay, so I'm going to switch gears from exponent rules to what a functions and what is a function. Really, we're just going to look at it from a kind of a visual understanding today, but the definition, so we are clear, is that each input has exactly one output. And if you don't really remember what that is, it's a function table. But so we would see that we would have like a table like this with x and y, and then you have some numbers 2, 3, 4, 5, 6, 7. The numbers 8, 9. The numbers in the table don't matter, but a function is saying that each of these only has one of those. That's a little confusing and kind of can be conceptually deep, although the definition is straightforward. My experience is that most don't fully grasp it because they don't have a good, clear visual understanding of what it means, even though they can see it. And we do have kind of that vertical line test, which we'll look at. But let's just look at these examples here. So mapping diagrams. So I have these people over here, and then I have these dates over here. And so these are what we're going to call, we're going to map the person to the birthday, right? And then we're going to decide if it can be a function or not a function. And why this is helpful is it allows us to understand what is and what is not a function in a very clear way. So first off, if I map Bill to October 31st and Jane to December 25th, Sarah to January 1st, Mike to February 14th, and Ted to July 4th, I'm guessing we would all agree that each person can have these birthdays, right? I mean, it's possible. I'm not sure if they are exact, but these are just hypothetical. So we can call this a function because each of these inputs, right? These are my input. The output is your birthday. So this would be your input, your output. So we're mapping Bill to his birthday. Now, I have another example right below, which is going to help. Actually, I have two examples, but we're going to kind of look at it. Sorry about the way these papers are coming off. But we're going to kind of look at it from a perspective of, let me see if I can fix this without giving too much away. Up here, it's not really giving anything away, but it's just I don't want you to be overwhelmed. So we're going to have another function, not a function. So what if I say that Bill, Jane, Sarah, Mike, and Ted all have a birthday on October 31st, right? These people, again, these are the x's and these are the y's, these are the inputs, these are the outputs. Each person could all have that same birthday, right? Bill, Jane, Sarah, Mike, and Ted could all be born on that day. So it's not wrong to say that. Therefore, this is also a function. Again, each of these inputs, this one only goes to 1. So visually, what happens in this next situation, we're going to create it so that we don't have a function to consider. And here's how we can see that to help us better understand it. We are now going to say, instead of all these people going somewhere, we're going to say that Bill now has birthdays. He has a birthday on October 31st, December 25th, January 1st, February 14th, July 4th. And that is saying that we have this one X, this person, having 5 different birthdays. So clearly that can't be true, so therefore that can't be a function. Whereas all the people can share one birthday, and all of them can have each different birthdays. So this is a mapping diagram, and of course it would come with numbers, but this kind of gives you a better understanding of why that is. So we have these 3 examples here to kind of look at that are visual. So how can we connect the idea of each input, each x having only one y? Well, if we kind of go down the x-axis, right, and we look at any moment, let's say I go to this location here, this is my x value, and if I look at my graph, so when we talk about the graphs also, the graphs are not the xy axis, they are the image on the xy axis. Like those are just, the xy axis is just the coordinate plane. So when we're talking about the graph, we are talking about this curve on this axis. Now, the arrows indicate this pattern continues forever, so if you're unsure about that, when you see arrows in this kind of situation, it considers that this curve is going to go up like this. This could be some sort of wave of some kind, but the point behind it is I know that at this point I only have one y. And we have what is called the vertical line test. So if I drew a vertical line down my graph, I would only ever intersect this curve once, which means this x input only has this one y output. Therefore, anywhere on this graph, I would only have one output for the input, so this is a function, right? This matches either this one or example 1 or example 2 from the mapping diagrams in terms of ideas. Well, let's look at this one. So if you're not sure, this is what we call, this is a quadratic, this is kind of a parabola curve. So it does, I apologize, it should go at an angle, not, let me make that a little better, it should go kind of at an angle instead of straight up. It's more off like that because parabolas don't go vertical. But the point behind it is that, again, I can pick any point on this and I can look here. This is my x, this is my y, and if I drew a vertical line, and I'll make it light. So I drew a vertical line, I will only intersect with this vertical line, and I could slide it. You can watch as my ruler slides across, right? At any given location, I only ever intersect it once. So what about on this example 3? Well, as soon as I put the ruler over it, I see that if I drew a vertical line, I would intersect it twice, right? Therefore, not a function. And this is a little tricky to think about, but let's go to the x-axis, right? This value would be our x value, right? But for this output, or for this input, I'm sorry, we would have this output right here, we'd have this y, and we'd have this other y. So it's like plugging, you don't go to a soda machine, right? And this is a good example, right? If you plug in $1 to, you plug in your dollar to the soda machine, and you get a soda, right? Unless you get 2 sodas accidentally, then the machine kind of malfunctioned, right? But you wouldn't get those, or a candy machine or whatnot, if it's functioning correctly. So it's just not a function. It doesn't mean we can't write the equation of this. It just means it's not a function because a function is very specific to the this definition. Each input has exactly one output, and we will look at it just a little bit further with tables, right? So how can you transfer kind of this information to some tables? Well, we have these 3 tables down here, and we can kind of look, right? And if we just go back to the mapping diagrams, we can now go back and think about, all right, well, as long as these are all going to something different, right? So 2 goes to 3, 3 goes to 4, 5 goes to 6, 7 goes to 12. So this is a function, but what about this one? 1 goes to 4, 2 goes to 4, 3 goes to 4, 4 goes to 4, 5 goes to 4, 6 goes to 4. This is a lot like example 2, where we have these people all sharing the same day, right? Because this is the y. So the x's, this is also a function. And I will be clear in just a moment as to why you can be certain of that. And here, right, we have, this is just like this last example where we have Bill having a birthday on the 1st, the 2nd, the 3rd, the 4th, the 5th, right? He just repeats his name here. So this is not a function. And so what we can gather from it is that if the x repeats, if x repeats in a data set, if x repeats in a set, it's not a function. Now, that's just a general rule. Let me move this up a little bit just so we can see that. It's just a general rule, but there are some situations where that might not be true. And those situations are only if, and I'll create an example here for you just because I think it's useful just to see an example where that might not be true. Well, what if I say 1, 2, then 3, 4, then 1, I don't put a number here, 5 and 6, but then I decide I want 2 there. So this is an example, although x is repeated, they had the same output, so it was really just a duplicate of the same ordered pair. So this is still a function, because in this situation, I just duplicated an ordered pair. So if I went back to the graph, it'd be the same point in the same location twice. So it's not really something that we would kind of dismiss as not a function. And so we will see connections, and we're not going to do any more here, but we will see connections, all these ideas to domain and range, and then how to calculate values within function notation. So hopefully that helps.